Hey guys, welcome back to the channel. In this video, we make 2D Minecraft in 12 hours. Since the time limit is so short, I need to think of what makes Minecraft, Minecraft. What is Minecraft known for? The first thoughts that I had for this were an inventory system, a procedurally generated terrain, and of course, building. I would also like to implement a crafting system as well, but I already knew that this wouldn't be possible with the time that I had. So, with that, I wrote a simple player movement script, added some cubes, and I had my first prototype of the game. I then added jumping, and that was basically the entire movement system that you needed for Minecraft. For the camera system, I wanted to use something that was easy to use and something that was fast to implement. I know from my previous experience, the Cinema Machine would be the perfect candidate for this. Within minutes, I had a fully functional camera system. Now it came to the part of this challenge that I was most excited about, procedurally generating the terrain. I never really knew how Minecraft did this. Thankfully, since Minecraft is extremely popular, I found some really great resources online. The link to these resources will be in the description. What I discovered from my research is that Minecraft uses noise maps to generate its terrain. More specifically, it uses Perlin noise. Perlin noise is a texture that is created with an algorithm. Looking at the two images on the screen, we see that the one on the left is Perlin noise, and the one on the right is a non-coherent noise map. As you can see in this picture, every pixel of the texture that is generated with the Perlin noise is directly related to its neighbor, giving the noise map a blurry-like appearance. The noise map on the right looks much more rigid and clear. This is because the pixels have no relation to their neighboring pixels. So what this would mean is that if the first tile to be spawned is at the maximum height value, then the next tile to be spawned will have a value that is similar to the first tile. Looking at the terrain that is generated from this, we see that this generates realistic looking terrain. If we were to use the noise map on the right to generate the terrain, we could get a terrain where the height of the first tile to be spawned could be the maximum height, and the tile to spawn after it could be the minimum height. This would continue for the rest of the tiles to be spawned. As you can see, this does not make for a realistic terrain spawning system. Using this knowledge, I created a tile map and filled it in with tiles to make sure that the basic terrain generating script worked. It took about 30 more minutes for me to get the Perlin noise working with the script, and this was the result. The terrain was generating quite nicely. You can also see that there are some trees being generated using Perlin noise. However, these trees look more like sticks and less like trees. This was caused by a bug where I was trying to generate the trees and the terrain at the same time, which was causing these stick-like contortions to be created. Digging a little deeper, I discovered that when Minecraft generates its worlds, it first generates the terrain, and then it adds things like trees and water bodies. Using this information, I directly applied it to my game, and the trees started to generate properly. Now you might be thinking that, wait a minute, you haven't added one of the most important parts about the terrain, the various different types of ores. In order to generate the ores, I gave each ore a frequency at which it can spawn, and a minimum height value so that, for example, we do not have diamonds spawning at the very surface of the terrain. I did experience some bugs along the way, such as the ore only spawning in a straight line, but aside from that, the implementation was straightforward. I also needed to think about the edge cases when someone plays the game. What if someone digs too deep and breaks the tile at the bottom? Well, Minecraft has a simple solution for this: the bedrock tile. In Minecraft, the player cannot break the bedrock tile, therefore they cannot break the bottommost block and go through the terrain. This was a simple implementation, as I just made sure that when the terrain was generating, the bottommost tiles of the terrain were bedrock. I then added a seed system to the terrain generation. For those of you who do not know how seeds work in Minecraft, a seed is a number that determines how the world will generate. So if I have a seed of 10,000 and create a world, it would generate a particular terrain. Now let's say that I delete this world and create a new world with the same seed of 10,000. The world that will be generated will be the exact same as the first world that was deleted. I did come across a bug with the water tiles. Since I was generating all the tiles in one tile map, and then adding a collider to the tile map, each tile would have a collider and the player would not be able to pass through. This works for every other tile in the game aside from the water tile. as you can swim through water, but you really can't swim through cobblestone, for example. To fix this, I created a new tile map without any colliders, and then added the water tiles to it. For the cave generation, I used Perlin noise just as the terrain. I initially tried to use a technique called Perlin worms. To put it simply, Perlin worms go through the terrain and it creates cave systems, just like how a worm would dig its way through the soil. The advantage to this over using Perlin noise is that Perlin noise creates unconnected cave systems like what you are seeing here. I spent about 30 minutes trying to implement Perlin worms, but I quickly realized that it would be far too time consuming to attempt it in this challenge. At this point, I pretty much had completed the terrain system and decided to work on how the player would interact with the world. To start off, I decided to implement how the player would place and destroy blocks. After about 30 minutes, I had a rough prototype for this interaction system. Left click to place a block and right click to destroy a block. As you can see, the blocks weren't placing in the proper y coordinate, but they were placing in the proper x coordinate. Fixing this was quite trivial and took a matter of minutes. What I did was I got the position of the mouse cursor and translated it to a position in the game. Using this position, I then spawned a tile on the tile map. I also decided to implement miniature blocks that you get when you destroy a regular sized block. This did not take much time at all, and I even included a small delay before the miniature block was destroyed. This was so that the player would notice the miniature block after they broke the normal sized block. I noticed that there was a rather common bug happening when the player spawned into the game. Whenever the player would spawn on top of a water tile, the player would spawn at the Y position of the lowest tile in the water tile map. This was due to the player spawner only using information from the terrain tile map. I had to provide information about the tiles in the water tile map to the player spawner to fix this bug. Next on my list was to implement the inventory system. The way I went about implementing this was when the player picks up a new block, it would go to the first open inventory slot. Then, when the player presses a key from 1 to 9, it would go to the corresponding inventory slot, and when this would be used in combination from a left click, it would result in the player being able to use the block in the selected slot. Now it came to switch it up and work on the art. The art was quite simple to make. I just needed some tiles, a sun, some clouds, and a player. All I needed was 11 different tiles for this game. The water tile, the grass tile, the dirt tile, the cobblestone tile, the bedrock tile, the coal ore tile, the iron ore tile, the gold ore tile, the diamond ore tile, the tree trunk tile, and the tree leaves tile. I only had a few hours left and still a lot to do. I had to create the artwork for the player as fast as I could. So within about 10 minutes, I had created a player sprite along with the player animations, and this was the result. It wasn't exactly my best work, but I would say for 10 minutes it came out well. After I had replaced the placeholder artwork with the final versions of the artwork, I noticed I had a major bug. At certain points when the player jumped, the player would get launched into oblivion. Through some testing, I found out that when the spacebar was clicked several times, it would add the velocity over and over again to the player, resulting in this extreme burst upwards. So I changed the jump system from a contact-based one to a timer-based one, and the player jumping was working once again. The scene still looked a little plain, so I decided to add a sun and some clouds. I created a cloud spawner script with 2 different clouds. The script was quite simple. All it did was calculate the top right of the screen and spawn the clouds there. These clouds would then move across the screen to the left from the right. I made 2 different clouds and decided to randomly flip their x-axis so that it would give some variation when they spawned. This is what I ended up with for the sun. The sun would just stay in the same position in the game, but through the camera's perspective, the sun would appear as if it was slowly moving. From my previous experience, I knew that sketching the UI before I tried to implement it would save time and make designing the UI easy. So this is exactly what I did. I went to my notebook and sketched a mock UI. And then once I was happy with what I had in my notebook, I went to Illustrator to design and create the buttons so that I could use them in Unity. This is what the original UI looks like, and this is what the updated UI looks like. Sound effects were something that I knew I could create quickly thanks to SFXR. I created 4 sound effects: placing a block, destroying a block, walking, and lastly a button click. I then spent 30 minutes in procedurally to create the background music, and this was the result. I decided to try something different and include some people playing Budgetcraft right after it was created.
Hello, so today I'm going to be trying Budgetcraft. I have played Minecraft before, so I'm excited to see this.
Alright, let's have a look at this this game. I'm about to press run for the first time. If I can find my mouse.
I like the cloud floating by. Hey. In the water. Hey. Okay. Looks good so far.
Okay, so right click is to get this stuff. So can I mine water? No, I can sink in water. Okay, can I mine this stuff? Yeah. Okay. Oh, let's go. We got gold.
Good.
So we got oils. Okay, bad. Cool. Nice.
Oh, looks like I see some coal over here.
Okay, can I? Okay, and then we can slowly ascend up out of water. Not bad, not bad.
Get back to the water and float my way up.
I like the fact that you can jump on water. That's probably one of my favorite things.
I'm gonna try building.
Nah, I'm just gonna like dig this as far as it'll go.
Gonna go explore some more. I think I'm gonna go mining again. Let's see what else we can find. Oh, I see some gold. Okay. See some gold. I wonder if some people fall on me. I'll get that later. I think I'm gonna go all the way to the bottom, see what I can get. Pretty deep down. Looks like I fit the bedrock. I guess that's what it's called. And I don't know a way to get back up, so I'm just gonna restart. And yeah, that's it for today. Thank you so much. I really enjoy playing Budgetcraft. I like how the colors are all so vibrant and it's easy to go mining. So it's building functions pretty straightforward too. Well, yeah. Thank you.
There are quite a few things that I would like to have implemented if I had more time. The first being cave generation using Perlin worms, more playtesting, and adding physics to the water. Well, that was the end of the video. Thank you all for watching. If you would like to support me, consider following me on Instagram and on itch.io. See you guys next time.